few more to go here. The equation of the tangent line to the curve at its point of inflection. So we got to figure out when does f prime double prime of x change sign, because that's where concavity changes, because that's a point of inflection. And then we got to take that x value, whatever that x value is, and we got to plug that into first derivative and find tangent line. Alright, so let's do that. We have y equals x cubed minus 6x squared. That means that y prime is going to be 3x squared minus 12x. And if I take the derivative again, y double prime is going to be 6x minus 12. If I were to factor that, I'd have 6 times x minus 2. So the only time that this could change sign is at x equals 2. Just to confirm it though, if I have f double prime of x here, let's look at 2 and before and after, so maybe 1 and 3. At 2 it's 0. If I were to plug in 1 into this, that's going to be negative, and if I were to plug in 3, that's going to be positive. So it does change concavity. It goes from negative concavity to positive concavity. We have a point of inflection. Therefore, x equals 2 is our point of interest. Well, then we have to find the derivative at x equals 2. What is y prime when x equals 2? Well, that's going to be 3 times 2 squared minus 12 times 2 if I plug in pieces from the first derivative. That means that I'll have 2 squared is 4 times 3 is 12 minus 24. Y prime is equal to negative 12. Why do I even need that? This is my slope. And I know x equals 2. And if I'm looking for the tangent line is really y minus y1 equals m times x minus x1. We have x1, that's 2. We have the slope, that's negative 12. What we need is y1. How do we figure out y1? Well, we got to plug it back into the original equation. So y, when x equals 2, is going to be 2 cubed minus 6 times 2 squared. 6 times 2 squared is 24, and 2 cubed is 8. 8 minus 24 is going to equal negative 16. So this is y minus 16 equals negative 12x minus 2. If I distribute, then I get negative 12x plus 24. We got y minus 16. I'm going to add 16 to both sides. Am I running out of space here? Let's give ourselves some more space. Add 16. So now I have negative 12x plus, well, if I put those two together, that's going to be 40. So y equals negative 12x plus 40. Is that one of my options? It is. It's B. I hope I did my algebra right. Might have made a small mistake. You guys can always check it. But the process is pretty correct here. Let's go to number 22. So we're saying that k is between 0 and pi. That's the first statement here. Then it's saying that 0 to k of cosine of 2x is equal to 1/2. So in other words, k is between 0 and pi. K is some angle here on the top of the unit circle, somewhere up here. And it's asking us to take the antiderivative of cosine of 2x and then set it equal to 1/2. And we're going to evaluate it from 0 to k. Well, let's go ahead and do that. If I have cosine of 2x, first I need to balance it a little bit. If I say u equals 2x, du equals 2 dx, that means that we need a 2 in here as part of this u and u prime thing. So if I put a 2 inside, I need a 1/2 outside. So I'm doing 1/2 integral from 0 to k, and we got cosine of 2 cosine of 2x dx. And we know that that's eventually going to be equal to 1/2. So we have 1/2 times the integral from 0 to k. Well, actually, let's go ahead and take the antiderivative. The antiderivative of 2 cosine 2x is just sine 2x. Excuse me. And have sine 2x. We're evaluating that from 0 to k. Well, I know some algebra here that I can do right away before I even start plugging in k and 0. I see that this 1/2 is equal on both sides, so I'm going to multiply both sides by 2. So that's asking me that sine of 2x from 0 to k is actually going to equal 1. Sine of 0 equals 0, so it's going to be minus 0. But the top, when I plug that in, it's going to say sine of 2k minus 0 equals 1. Well, if I know that if I'm between 0 and pi, and I'm using sine as my function, then right here, my angle, my k, well, I don't know what k is yet, but my theta, the angle that's in question here, is going to be at pi over 2. Because sine of pi over 2 equals 1. And I know that sine of 2k equals 1. Notice the parallel, sine of pi over 2 equals 1. Then that must mean that pi over 2 is 2k. So pi over 2 equals 2k. If I divide both sides by 2, then I get pi over 4 equals k. B would be my answer. Ooh, number 23, one of the 1, 2, 3 questions. Which of the following properties of a definite integral are true? We know that if k is a constant, then it can be pulled in and out of a function. We also know that we can split a function here. So 1 is true and 3 is true, but 2 is not. And we're going to see why in a second. Right here, we can split a function at a point C in the middle. And we can say this area from A to C plus this area from C to B is equal to the total area from A to B. That makes sense. What doesn't make sense is here. We see this x and it's being pulled out in front. That you cannot do. You cannot pull out a function. A function does not go in and out of an integral. Why? Because it changes. The only reason the constant comes out is because it's constant. It doesn't change. Therefore, it has no effect on the change of the variables in the function. It's just going to multiply by a constant in the end, the same as it would in the beginning. So the answers would be 1 and 2, or 1 and 3. Whoa, almost got that wrong. Final 5, we're almost there. Ooh, this one, rough. Well, it is a chain rule. We have, this is really saying f prime of x, or f of x is equal to e to the 2x, and we got plus 1 to the 1/2. So an f prime is going to be 1/2 times e to the 2x. Let's do this one piece at a time, actually. If we're doing a chain rule, that means we're going to have 1/2, and then up here is a negative 1/2. We have e to the 2x plus 1, and then out here is going to be the derivative of the inside, which is just e to the 2x times 2. Now, how do I do that so quickly? Well, the derivative of e to the u is equal to e to the u du, or du dx, however you want to say it. If I'm taking the derivative of this and multiplying by it. It's like a chain rule within a chain rule. Well, let's start simplifying what we got here. This is the same as 1 over 2 times e to the 2x plus 1, that's in parentheses. And then on top I have 2 times e to the 2x. Well, first the 2's reduce. Now I can go ahead and plug in 0. F prime is 0. It's going to be e to the 0 over, oh by the way this is square rooted, the square root of e to the 0 plus 1, which is equal to 1 over square root of 2. If I look at these possible options, that's not any of those, so I need to rationalize the denominator. So if I multiply the top and bottom by that square root, the bottom will become 2. The top will become square root of 2. Now my answer is C. Ooh, we got a lot going on here. First, notice that it's asking us for second derivative, not just first. Second, notice that we have to do implicit differentiation. This is going to be a little bit crazy, but I'm going to show you guys something that I think might help us. What I feel like I can do is I can actually factor out a y from each of these. So if I look at this, I say that this is really 2. I don't even need to factor out a y. We got 2yx squared. How do I know these are the same? Because x squared y is the same as yx squared. It's like ab and ba. Doesn't matter what order you multiply them in. 2 times 3 is still 3 times 2. So then I have 2yx squared equals 6. Well, I can divide both sides by 2. Then I have yx squared equals 3. And I divide both sides by x squared. That means that y equals 3 times x to the negative 2. That tells me that y double or y prime is going to be negative 6 times x to the negative 3. Y double prime is going to be equal to 18x to the negative 4. That's not bad at all. Because if I'm trying to plug in the point 1 here, I don't really care about the 3 because I don't need to plug that in. Y double prime is going to be 18 times 1 to the negative 4. And 1 to any power is still 1, so it's just 18. That was a lot faster than I thought. But it came from recognizing that sometimes you can do algebra first. It's a good strategy. If you can simplify, do it, because it makes the rest of the process simple. Just kiss it. You guys know what kiss means? I hope you do. It means keep it simple. And then this last word can be whatever you want. Keep it simple, silly. The base of a solid is the region in the first quadrant bounded by the line x plus 2y equals 4. So first, let's give ourselves some pictures here. Just to make our eyes get a little break. So there's our first quadrant. We have the function x plus 2y equals 4. Now I actually know a little bit about that. I recognize that it's a linear function. I also recognize that I can find the x and y intercepts pretty easily by substituting 0 for the opposite variable. So if I want to find the y-intercept, I plug in 0 for x. So 0 plus 2y equals 4, y equals 2. And x plus 0 equals 4, x equals 4. So that means that x equals 4 and y equals 2. And this is a straight line. Thankfully I have a straight line tool. And now let's see what we're trying to do after that. I just want to get that kind of information out of the way. And the coordinate axis. What is the volume of the solid if every cross-section perpendicular to the x-axis is a semicircle? Well, let's talk about semicircles for a second. If I have a semicircle, looks kind of like this, and I have a base to that semicircle, this red line is the same as this red line here. Well, that base, let's call it B, is our function up here, especially if I solve that for y. The reason they put it in terms like this, and you guys might not recognize this, is that you could go in either direction. We can go in dy direction. It's perpendicular to the x-axis. Actually, take that back. We have to go in this direction because our base is perpendicular to the x-axis. So we're going to be doing the integral from 0 to 4. We've got to figure out the area of a semicircle. Now I put up here 0 to b, but I really meant 0 to 4 because we know that that's where we're ending here. We're going from 0 to 4. But we need to find what the area of a semicircle is in terms of b, a function of x, which equals our base. Well, this base here, let's say we want to find the area of a semicircle. The area of a semicircle equals half pi r squared. Well, in terms of b, if I need b is really 2r. So b over 2 is our radius then. And that means that we have 1/2 pi times b over 2 squared. We're going to make that substitution. Now if I were to multiply this out, that would tell me that I have 1/8 or pi over 8 times b squared. If I were to multiply things out and simplify a little bit. So that means that the area of a semicircle is pi over 8 times b squared. So that means this integral is really going to be pi over 8 times the integral from 0 to 4 of b squared, which in this case is, let's see what we get. That's going to be 4 minus x quantity squared times 1/2 is equal to y. Pardon me, that's jumping ahead a little bit there. What I'm trying to do, I actually did that incorrectly. What I'm trying to do is take this original equation and solve it for y. So I subtract the x, divide by 2. Then I'm going to have 2 minus 1/2 x equals y. So that's what we're going to have in here. 2 minus x over 2. And then this right here, the area of a semicircle is b squared. So we have to square that. So we got a lot of simplifying to do here. Well, let's go ahead and get started. First, we got to multiply this out. We got 2 minus x over 2 and 2 minus x over 2. That's going to become 4. And 2 times x over 2 is just negative 1x, and we got 2 of those, so that's minus 2x. And then x over 2 squared is really x squared over 4. And we're going to evaluate that. Actually, we got to take the antiderivative of that. So the antiderivative of 4 is really 4x. And the antiderivative of 2 is going to be x squared. 2x, pardon me, is x squared. And the antiderivative of x squared over 4 is going to really be plus 1/4 times x cubed over 3. So it's really x cubed over 12. If I were to put all those terms together. Evaluating that from 0 to 4. And we're going to multiply all of it by pi over 8. A couple of things to remember. Because we have a 0 on the bottom and each of these terms has a 0, the last half of it is going to be minus 0. We just really need the first 3 terms. So we have 4 times 4 minus another 4 times 4. Hey, that's convenient. Let's get rid of those right now. Then we have 4 cubed over 12. 4 cubed is really 64 over 12. And we're going to multiply that by pi over 8. So we got pi over 8 times 64 over 12. Hey, look at this convenience. 8 and 64 reduced to 8 and 1. And 8 over 12 reduces to 2 and 3, because 4 goes into 8 twice and into 12 3 times. So that means I have 2 pi over 3. The answer is A. Here's the word. Last one. Oh wait, we got 2 more. Just kidding. We got 2 more. Particle moves along the x-axis so that anytime its position is given by x of t here, for what values is the velocity of the particle increasing? The velocity, notice that they underlined it like it was important. The velocity is increasing when the acceleration is positive. How do I know that? Because that's like saying the position is increasing when the velocity is positive. We basically know that something's either increasing or decreasing when its derivative is positive or negative, respectively. So if I have x of t equals t plus 1 times t minus 3 to the third power, I'm going to go ahead and leave that as is and just do a little bit of product rule and chain rule action with it. So let's look at x primed of t, which is our velocity. And then we eventually need to get down to acceleration. Well, x prime of t, if I look at this, actually I could split it up into 2 terms. I'll have, this is going to be t times t minus 3 cubed plus 1 times t minus 3 cubed. So let's do the first term here. T times t minus 3 cubed. We'll color code this. We'll do this one in blue. So the product of this, or not the product, yeah, it's going to be product rule. U prime v plus v prime u, here's our u and v, is going to be 1 times t minus 3 cubed plus the product of v. V primed is 3 times t minus 3 quantity squared, and the derivative of t is 1, so that's just 1 there, times t. And we got, of course, this one here, and the derivative of the second piece, which I'll color code in red. It's going to be a chain rule, so it's going to be plus 3 times t minus 3 to the second power. So we have a lot of action going on. Let's keep it going. So now I have 3 pieces here. Let's do this first one in green. The second term we'll do in orange, and the third term we'll do in gray. Oh, that was supposed to be gray. Actually, how about brown? Brown. Green. So the derivative of the first one. This is acceleration, by the way. When we take the derivative of velocity, now we're down to acceleration. And then we eventually want to set that equal to 0. Why? Because that's going to tell us when we have critical points that we can see where it's increasing or decreasing. Well, this first one we have 3 times t minus 3 to the third power. So that's going to become 3 times t minus 3, pardon me, to the second power, plus, now the second one we have u prime v plus v prime u. The derivative of this first term, I'm going to treat this as kind of the split here. The derivative of the first term is going to be 6 times t minus 3 to the first power times t plus 1 times 3 times t minus 3 quantity squared. Then we have the last and final derivative here, which is in red, which is going to be plus 6 times t minus 3 to the first power. Man, that is a lot of work. You know, this might have been easier if I just multiplied it all out to start with. And in fact, that's what I'm going to do. I'm going to redo this, and you guys are going to say, why are you doing it that way? Because I want to show you how that gets so complicated because we didn't simplify it. We didn't spread it out to start with. Whenever you take a function and split it up into separate terms, that makes it usually a lot easier to work with. So let's multiply this out. First I need to figure out what t minus 3 to the third power equals. Well, let's figure out what t minus 3 squared is. Well, it's just a simple kind of FOIL thing, but if I needed to do the box multiplication, I'm really looking at t minus 3, t minus 3. I'll have t squared minus 3t minus 3t and plus 9. So that's going to be t minus 3 squared is equal to t squared minus 6t plus 9. I need to multiply that by another t minus 3. So I'm going to take all this and multiply it by another t minus 3. You guys are probably asking, why are you doing this? It's so much easier, trust me guys. So we have t minus 3. So now we multiply here. T squared times t is t cubed. Negative 6t squared. We have 9t minus 27. And then negative 6t times negative 3 is 18t. And t squared times negative 3 is negative 3t squared. So if we're to combine these pieces, you can usually combine them on the diagonals when the degree is pretty standard. It doesn't have any mixed terms in there. So we got t cubed minus 9t squared plus 27t and then minus 27. You're probably saying, why is he going through all this problem, like all this trouble? Because in the end, it's going to be worth the pain. It's going to be worth our struggle. To figure all this out. So I got to multiply all that by t plus 1. T cubed times t is t to the fourth. T cubed times 1 is t cubed. T times negative 9t squared is negative 9t cubed. Negative 9t squared times 1 is negative 9t squared. 27t times t is 27t squared. 27t times 1 is 27t. Negative 27 times t is negative 27t. And negative 27 times 1 is negative 27. Well, let's see what cancels and reduces and such. I notice that this 27 and the negative 27t are going to cancel out. I notice that negative 9t squared and 27t squared is going to become 18t squared. I also notice that negative 9t cubed and t cubed is going to become negative 8t cubed. And then we have t to the fourth here. Now, I don't really care about this constant. Why? Because I'm taking the derivative. So this is x of t. What's x prime of t? Now this is going to go so fast. Watch this. 4t cubed. I'm going too fast for my own good. Minus 24t squared. Plus 36t to the first. Minus 0, of course. X double prime of t, which equals the acceleration, is equal to 12t squared minus 48t plus 36. So we got to figure out when that is increasing. Well, let's first start by factoring this a little bit. If I were to factor out a 12, then I'll have t squared minus 4t plus 3. Factor that even further. I'll have t minus 1 and t minus 3. So I know that I have critical points potentially at 1 and 3. Now I got to check them. So I'm looking at a of t and v of t and t. I'm going to be doing a little sign chart here. So we need to check at 1 and on either side. And we also need to check before. So we got a 1 going here, a 3 going here. So we need 5 boxes. There we go. So we have a 1 and a
3, let's check 0, 2, and 4. We know at 1 that the acceleration is 0, and at 3 the acceleration is 0. But let's see what happens when we plug in 0. If I plug in 0, I get a negative times a negative. That's going to be a positive. If I plug in 2, that's going to be a positive times a negative. That's a negative. If I plug in 3, that's going to be a positive, or a 4, that's going to be a positive and a positive. So that's positive. So that means that this is increasing, then decreasing, then increasing. So from negative infinity to 1, I'm increasing. And from 3 to infinity, I'm also increasing. So let's see what options we have here. So from, a particle moves along the x-axis. So t has to be greater than or equal to 0. Or even greater than 0, I guess they're looking at here. That would mean for 0 to 1. So t has to be less than 1 or greater than 3. D would have been our answer. Last problem of the night, and we are done. At any time, t greater than or equals 0 in days, the rate of growth of bacteria population is y prime equals ky. Y is the number of bacteria present. K is a constant. Population, the initial population is 1,500. That's our constant. Remember how we have c e to the kt. Well, this is going to be 1,500 is our c. And the population is quadrupled during the first 2 days. By what factor will the population have increased during the first 3 days? Ooh, that's interesting. It's quadrupled during the first 2 days.